Yeah, do that thing. Join again. All right, so let us start the class. Actually, I have been traveling. Just now I reached home. Okay, now that's why I'm a bit late today in today's class. Okay. Okay, so we were doing this chapter combustion and flame, right? Okay, so in the first class we learned about combustion. What is combustion? So basically, it's a chemical process. Right now, it's a chemical process in which basically the substance will go under reaction with air. Getting it, guys? It goes under reaction with air, and in this we get to see that what will be formed, what will be released. Yes, we learned that heat will be released, light will be released. Right now, then that substance will also release some byproducts also, depending upon the type of fuel it is. So there can be some byproducts also. Right now, so those were the things we learned, and also in the previous class we learned that there are some substances which readily catch fire, meaning that they will easily catch fire, while some of the substances are not able to catch fire easily. They are non-combustible in nature. Can you guys quote some examples of the combustible and non-combustible substances? Yes.
Wood is a non.
Wood. No, wood is a combustible substance. No?
Coal. What's the
Coal.
difference? What's the difference between
Water, sir,
combustion?
what?
Okay.
Sand.
Okay. What's the difference between? Repeat again.
Water and sand.
Can
Alif, just hold on for a minute. Sundus, please complete your question.
combustion and non-combustion. Like I didn't get it.
Okay. See, basically the thing is that those substances which will easily catch fire, they are going to be called as combustible substances, like a paper or coal or wood. Then we have substances which are not going to catch fire very easily. Right now, you have example of common examples are sand, water, glass. These are the substances that do not catches fire easily because their ignition temperature is usually very high,
Sir,
and because of their different chemical properties also. Yeah.
sir, minerals also a non-combustible, right?
So minerals are basically what? Minerals are basically different type of elements are called as minerals. Different type of elements are basically minerals. So in minerals, you will be having different things. For example, carbon is also a mineral, and coal is made up of carbon. We see that coal is a combustible substance. Or say, for example, silica is also a mineral, no? While the sand is made up of oxides of silica. But we know that sand is a non-combustible substance. So although both carbon and silica are minerals, so coal is made up of this mineral carbon, it is combustible, while sand is made up of this mineral silica, which is non-combustible. Hope you guys are getting it.
Yes, sir.
Okay, no?
Sir.
Sir, rock is a non-combustible, right?
Yeah, we can say that rocks are non-combustible. Okay, no? So we can say that. Okay. So we learned that combustion is basically a chemical process in which substances reacts with oxygen to give off heat and light. That is simply called as combustion. We are going to learn about combustion of different substances. We are going to learn about combustion of different substances. For example, let us talk about combustion of magnesium, for example, how magnesium burns. Okay, now how magnesium burns, for example. Hold on for a minute. The first case we have example of combustion of magnesium. See, magnesium would be burning in the presence of air to give magnesium oxide heat and light. Magnesium burns with oxygen to give off magnesium oxide. magnesium oxide. Apart from this, heat and light is given off. And this process is basically combustion. Okay, now. So if a magnesium ribbon, if you have got a magnesium ribbon and if you were to burn it, it will give a very dazzling light. It gives a very dazzling light. Okay. Am I visible to everyone by the way in the class?
Yes, sir.
No, sir.
Yes, sir.
Now I can.
Okay, okay. Great. So talking about this magnesium, upon burning a magnesium ribbon, for example, you have a magnesium ribbon, you burn it, it will liberate a good amount of light along with some heat also. So that is one such example of combustion. Another example of combustion is burning of charcoal, combustion of charcoal, combustion of charcoal. So charcoal is what basically? Charcoal is mainly carbon, no? Charcoal is basically mainly carbon. So if you hold a piece of charcoal with a pair of, let's say with a pair of tongs, you're holding a piece of charcoal. Right now, say you are holding a piece of charcoal and if you were to burn it near a candle flame. So here what is going to happen? Charcoal is going to react with the oxygen in the air. It reacts with the oxygen in the air to give off carbon dioxide, heat, and light. So here carbon dioxide gas is also released in this case. Getting it, guys? So any fuel, any combustible substances that will consist of carbon upon burning, it is obvious that it is going to release carbon dioxide gas. Right now? So here charcoal has undergone combustion. Right now? That is the simple thing about it. Furthermore, we can have several other examples. We can have example of combustion of paper, combustion of wood, etc. Now you guys would notice that there's one thing that is common in both the reactions, in the first reaction and in the second reaction. Both of them requires oxygen. So oxygen is a necessary condition for combustion to take place. That's a necessary condition, right? So oxygen is kind of a supporter for combustion. In most of the cases of combustion, oxygen is provided by the air around us. So in a way, air is, we say that it's a supporter of combustion. So note down this one thing that we say that air, particularly in air, we have oxygen is a supporter of combustion. That's the first thing. Okay, now. Now, if you were to talk about, see, like we take in food now. Food is what? Food is fuel for our body. Food is fuel for our body, and during respiration, what does happen? The digested food, like glucose, is broken down by reaction with oxygen in the body to produce carbon dioxide, water, and energy. We learned, like in our previous classes or in your previous standard, in standard 7th, you must have studied about respiration, I believe, where what happens, the digested food, once it is taken up by our cells, there what happens, further that digested and absorbed food is broken down in the presence of oxygen to liberate carbon dioxide, give us with energy and water also. Right now. So we had one such a special case during respiration. The digested food, what happens? Food, particularly in food, we are talking about glucose here, reacts with oxygen to give out heat energy along with carbon dioxide gas, and water is also released. Are you guys getting it? So we say that respiration, in a way we can say that it's also a combustion, because heat energy is given off in the case of respiration also in the body. So respiration is kind of a slow combustion of food which takes place in the body to produce heat energy. Huh? Are you guys getting it, what I'm trying to say? So respiration is a slow combustion which produces heat in our body. Is that much clear to everyone?
Yes, sir.
Yes, sir.
Good. Now we know that like if you were to have some other examples of combustion, you know that we all have seen the brown rust present on iron nails and other iron objects. What is that rust? That rust is mainly formed when iron slowly combines with the oxygen present in air, isn't it? Or not just air,
Yes.
but it particularly will be reacting with damp air, moist air to form iron oxide. No? Like you would be aware of this. Iron reacts with damp air. Damp air consists of oxygen plus water. Here what happens? Ferrous oxide is formed. And this iron oxide is formed right now. So this process of rusting of iron is also one such example of slow combustion. Because remember in the definition we have learned that combustion is a process where substance reacts with oxygen. Then question comes, does it give heat and light? So the answer to that question is that the rusting, it will liberate a very small amount of heat. It will release very small amount of heat, but no light. So another example we have of rusting of iron. Rusting of iron. What is formed in this process? You guys answer to me. What is the formula of rust? That is iron oxide. Okay, now let me write this over here. We have iron, that is Fe. Fe is the symbol of iron, by the way. Like in the next class, we'll be learning about periodic table. The periodic table that was given by Dmitri Mendeleev. There you will get to learn that different elements are represented by different symbols. So iron in Latin it is called as ferrous. Okay, now so the symbol is Fe. So iron is going to react with oxygen and water to form iron oxide. Iron oxide is nothing but the rust. The formula to this is Fe2O3. So this is also one such example, but it's a slow combustion. Are you guys getting it? Respiration is also one such example of combustion, but that is also slow combustion. Hope everyone is getting it.
Yes, sir.
Okay. Okay. Further, we know about sun. Sun produces. Also, let me just conclude this thing by the way. Here you will observe that little heat is also given off. Little heat given, but no light is emitted in this example. Okay, then we look at sun. Sun produces both heat and light, no? And the heat and light produced in the sun are not due to ordinary combustion, not due to any ordinary combustion. Right now, what happens? The combustion, one of you, someone's mic is on, please turn it off. There's some background noise. Alif, turn it off.
Okay, sir.
Hmm.
Just the art game.
See, in the case of sun, what happens? Combustion is happening, but is there oxygen? You guys tell me.
Can you repeat?
Is there oxygen available to sun? Is oxygen available to the combustion that is taking place in the sun?
No, sir.
No. Although it's not a normal combustion, it is not due to an ordinary combustion that we study on
It's,
Earth.
helium and hydrogen, right?
Exactly. So there, what is happening in the sun? Heat and light are produced due to nuclear reactions in which what happens? Hydrogen is converted into helium. You guys are getting it? So in sun, heat and light aren't produced due to any ordinary combustion. There, what is happening? Nuclear reactions are happening. In nuclear reaction, what happens, guys? The hydrogen splits into hydrogen forms helium ions. Okay, now where hydrogen is converted into helium. And due to this conversion, lots of heat and light is emitted out. Is that clear to everyone?
Sir.
Okay. So hope that much is clear. Okay. Also, do tell me few questions like, is soil a combustible substance?
No.
No, sir.
No. Is brick a combustible substance?
No, sir.
No,
Okay.
sir.
Iron nails?
Yes,
Yes,
sir.
sir.
No, it is not a combustible substance. The definition of combustible substance says that any substance that will easily catch fire. You don't have to put lots of effort into burning it. The melting point of melting point of iron is very high, right now. So you have to provide lots of energy to this, right now.
Sir,
Okay.
iron will get the rust, right?
Iron will get rusted. Iron will get
Ah.
rusted, but it is going through the process of combustion, but it's a very slow combustion right now. The usual definition for combustible substance is that any substance that can undergo combustion, that can easily go under combustion, they are called as combustible substances. While any substances that will not easily undergo combustion, they are going to be called as non-combustible substances. So do you, like, for example, if you were to have a matchstick, so you can easily if you were to have falling substance, for example, you have dry grass, basically, let's say you have straw, or you have any cloth, whether it be natural or synthetic, or whether you have charcoal, or you have coal, or you have like a LPG, you have CNG, or you have kerosene oil. All of these can be easily burnt with just a matchstick. You can have other examples like petrol, you can have example of diesel, alcohol, you can have example of magnesium ribbon.
Sir,
Yes,
our body is a non-combustible or combustible?
our body. See, our body also catches fire, although not very readily. Like if you were to just have a matchstick, if just by a matchstick, the human body will not catch fire. So human body can't be said to be a combustible substance. But the thing is that once we look at the scientific consensus, there are incidents where we see that human body will also ignite. It can also ignite, obviously. We have several accidents happen where the human body ignites, because the thing is that our body sometimes, if the surrounding temperature reaches too high, I mean to say that the temperature reaches too high, and you know that our body has also got different type of combustible compounds are there inside the body. So the human body, kind of, we can categorize it as a combustible substance, but you need to have, but if there's a lots of heat, only in that scenario. Yeah, someone had a question. Someone was posing a question, by the way.
Sir, charcoal can catch on fire?
Charcoal can?
Catch on fire? Because while we were discussing about coal and petroleum, you said that charcoal cannot catch fire, but it heats up.
See, basically the thing here is, now, it will not burn with a flame. It does not mean that it
Yes,
will
sir.
not burn. Okay, now it will ignite, it will burn, but without a flame. It will simply glow. So
it does
whether
not produce any fire.
Yeah, it does not produces a flame basically, but that doesn't mean that it is not going through the process of combustion. Charcoal, upon heating, what happens? Mainly it is carbon, and carbon is a non-metal. So when it is burned, it will react with oxygen right now. So if a substance goes under reaction with oxygen, so thereby we say that it is doing combustion. Okay, now. So yes, charcoal actually does that.
So,
And that's a different thing, whether it produces a flame or not. That's a different thing. Okay, now. Hope
yes,
that is
sir.
clear. Okay, now. Although talking about the human body, although just holding a match to your hand probably is not going to get you on fire. It not cause that much of burn. But we know that our body has got fat tissues are there inside our body. You know why a human body, whenever there's an accident, why is it that the human body starts to burn? No? Because there are fats. No, fat tissues are present in under the skin. Are you guys getting it? Hmm? So there are enough fat present inside the human body that it can lead to the body getting on fire. So eventually the human body will go under combustion. Okay, na? Is that clear to you, to everyone?
Yes, sir.
Okay, so let us. We were talking about combustible and non-combustible substance. So moments ago, we had several examples. So we had the one example of combustion of magnesium. Then you have combustion of charcoal. Then we had this example of respiration. That is also combustion, but it's a slow combustion. Rusting of iron is also a slow combustion. Then in the case of sun, actual combustion, a normal combustion is not going on, but a nuclear reaction is going there in the sun. Right now, and what happens in the nuclear reaction in sun? What is happening there? Not just in sun, it happens in other stars also. So there are two kind of reactions that are happening here inside the sun: fission and fusion. Nuclear fusion reaction and fission takes place. Like in the fusion, what is going to happen? Like say you have a sun. In the sun, what happens? The two nucleus of different atoms, it might merge together to form a single atom having heavier nucleus. Try to understand this, or maybe just let me just keep this simple for you guys. Basically, what is going to happen now? Say there are two nucleuses. They merge together. And merging is called as fusion. Merging is, what do we call this merging as? Fusion. Okay, so say they have merged to form a atom with a heavy nucleus. Right now, what are these things, by the way? These are the nucleus. So if two different nucleuses combines together to form an atom having higher nucleus, so this will release lots of energy. Apart from energy, it will release neutron, and it will also be releasing this helium that we talk about. So normally, what do we see that? Nuclear reaction, helium is being produced. And where are these nucleus coming from? These nucleus are coming from the hydrogen atom. Hope you guys are just having a slight idea of this. Although no need to go into depth in a depth about these things. You will be studying about it in higher classes. Okay.
Okay,
Now
sir.
let us understand what are the necessary conditions required for combustion to take place. Why an activity? First of all, let us try to understand few things. For example, in this activity, although like this activity 4.1 gives you a different materials and you have to categorize them as combustible and non-combustible. You have the NCERT textbook. All of you have that now. So in your book only, using a pencil, you guys will do this. Okay. Let us discuss this activity 4.2. By the way, I'm supposing that everyone have NCERT textbook with them. Everyone have, no?
Yes, sir.
Don't
Yes,
have.
sir.
Okay, if there's someone who don't have the NCERT textbook, they can use the soft copy. They can download the PDF. See, in the first image, what is happening here? This glass cylinder is rested upon two wooden blocks. So air can pass through beneath. Air can pass from here now. So we see that the candle, we can observe that candle is not turning off. It is still glowing. In the second case, as soon as you remove the wooden blocks, the fire extinguished. The flame went off. Right now?
Yes, sir.
In the third case, what happened? What have you done here? You have closed it from the top also. Here also it went off. So what can we conclude from this activity basically?
That oxygen is essential for burning.
Exactly. Air, basically that consists of oxygen, is necessary for combustion. Right now. So the first thing which we learned, that the necessary conditions for combustion. So first thing is that we require air, that is basically oxygen. Okay, now you guys think of some other necessary conditions. What else do you need for something to light? Yeah,
The source of fire.
source of heat, source of fire or source of
Yes,
heat.
sir.
Good. Right now, we say that we are particularly referring to ignition temperature here now. Before any combustible substance can catch fire, it needs the ignition temperature. What does it need? It needs the ignition temperature. And what is basically ignition temperature? The lowest temperature at which a substance catches fire and it starts to burn, it is called as ignition temperature. So for example, if you were to hold a piece of wooden block and you light it using a matchstick, will it catch fire easily? Is it going to catch fire?
Sir, can you repeat?
You have a piece of wood and you are trying to light it using a matchstick. Is it going to catch fire?
No, sir.
No, sir.
No,
No.
sir.
Okay, then let's say you have a piece of paper now instead of this. Okay, now is it going to catch fire?
Yes,
Yes,
sir.
No,
sir.
sir.
It is going to catch fire, no? Using a matchstick, you can easily burn a paper, isn't it?
Oh,
So why this
I-
one
I
isn't catching?
uh,
Mhm.
I thought the matchstick will burn.
Oh, no issues. So the paper is going to catch fire. The reason is that the minimum temperature required to burn them were different here now. It requires much more temperature. This wood requires much more temperature, and this much temperature was sufficient for this paper to burn. Right now.
Okay.
So we say that the lowest temperature at which a substance catches fire and it starts burning is called its ignition temperature. So ignition temperature is also one of the conditions required for any substance to undergo combustion. Right now. So for example, this ignition temperature of this paper is 233 degrees Celsius. So it has to be heated up to 233 degrees Celsius. Only then it will be catching fire. Right now. So a substance, particularly a combustible substance, cannot catch fire as long as its ignition temperature is lower than as long as the temperature is lower than its ignition temperature. Hope you guys are getting it.
Yes,
Okay,
sir.
na? So for example, if you were to talk about, let us say you have a petrol, like what is the minimum temperature required for burning petrol? So we say that the minimum temperature required for petrol to burn is somewhere around petrol or like diesel. It will, although it is going to vary, but yes. Repeat again.
150 degrees.
Not 150. It is going to remain somewhere between 245 to 280 degrees Celsius. Somewhere between that. Right now. So hope you guys are getting it. Although there are different type of ignition temperature also, like later on you might study like self-ignition temperatures is also there right now. But that is the temperature required. So it is different. So different fuels are going to have different ignition temperature. Okay, now that different fuels are going to have different ignition temperature, and that will also depend upon their state. Like solid fuels are going to have a higher ignition temperature. Liquid and gaseous fuels are going to have lesser ignition temperature. Hope you guys are getting it. Okay. So say for example, you have like cloth or alcohol or kerosene, petrol, LPG, CNG. These are going to easily catch fire. And upon burning, they are going to give a flame also. Upon burning, they are going to give flame also. While if you were to have examples of like coal or wood or cow dung cakes, they are having a higher ignition temperature right now. So we have got two type of substances, one that has low ignition temperature, one that has higher ignition temperature. And the low ignition, the fuels that are having low ignition temperature, they catch fire easily, hence they are called as inflammable substances. Getting it, guys? So first of all, let us define ignition temperature. Who will define ignition temperature? We have learned about it. Anyone?
Can you repeat again?
Someone define ignition temperature?
Sir,
The
can you-
minimum temperature for combustion.
Okay. Aleph, you also define it?
Can you tell one more? My internet was low.
My question is, what is ignition temperature?
The temperature that catch ignition.
Sundas?
Yes, sir. The temperature that requires to cause combustion.
You guys are forgetting one term in definition. You need to use this term, lowest temperature or minimum temperature required. Okay, na? It's the lowest temperature required for a substance to catch fire. Okay.
So,
Yes.
can you explain that ignition temperature again?
Okay. No issues. See, say for example, you have a piece of paper, and say it will catch fire. It will start burning only when it gets a temperature of 233 degrees Celsius. And normally, what do we know that when a matchstick is produced, lots of heat is generated. Like for example, upon burning a matchsticks, we get to see that around 400 to 600 degrees Celsius temperature is produced. So this is more than what is required. So yes, it is obviously going to catch fire. This paper is going to catch fire now. So once you lit a matchstick near to this paper, this starts to catch fire and it starts to burn right now. Although you not needed to provide it 400 to 600 degrees Celsius, you just needed to provide it a temperature equal to 233 degrees Celsius. 200 equal to 233 degrees Celsius, or if it is more than it, that is also good. So we say that the minimum temperature that is required for a given substance to catch fire is called as its ignition temperature right now.
Yes, sir.
So it has to be heated at least to this temperature. What is the limit? Limit can be any much. It could be up to 1000 degrees Celsius, 5000 degrees Celsius. But the minimum temperature required is 233 degrees Celsius. So that is the thing. Okay, no? Yes.
Sir, when we even perfume catches on fire quickly, right?
Yeah, perfume also catches fire quickly.
So why is that so? What is present in perfume?
Because alcohol is found in it, no? Alcohol is found in the perfume. Basically, perfume is what? Spirit, right now. So perfume consists of alcohol, right now. So you
Yes,
would be having different type of alcohols, although it is not the consumable alcohol, right now. But
Yes,
it
sir.
consists of
Sir,
different type of alcohols.
Vaseline is flammable.
Which thing?
Vaseline.
Gas cylinders.
No, sir. Vaseline.
Uh,
The
I-
Vaselines.
okay, Vaselines. Are Vaselines combustible?
Yes, sir.
Vaseline that you use as a moisturizer, no? That thing you're talking about.
Yes, the most.
Vaselines are not combustible. However,
sir,
you see that.
But the Vaselines have petroleum.
See, that's a different type of hydrocarbon. Not that's a different type of hydrocarbon in it. Not all the hydrocarbons are combustible in nature. Okay, no? See, the thing is that the way how it is designed for our use and for our storage is that it is not flammable. But if it is heated extreme temperature, say that if you were to heat Vaseline to temperatures more than 380 or 400 degrees Celsius, then only it is going to catch fire. If you were to heat it to a temperature more than 400 degree Fahrenheit or degree Celsius, degree Fahrenheit, I mean to say, by the way, then in that case we see that it happens. Even in summer season, you see that it does not catch as fire, because even if the temperature reaches 40, 45, or in some cases 52 degrees Celsius also, so it does not naturally happen. So hope that answers. Okay, no? Okay. Furthermore, we were talking about, based on the ignition temperature, some fuels are having low ignition temperature, some fuels are having higher ignition temperature. Ignition temperature, low ignition temperature, and then you have high ignition temperature. So the fuels that are having low ignition temperature, they are called as inflammable substances. What do we call them as? Inflammable substances. So the substances, let me write this over here, the substances which have a low ignition temperature and can catch fire easily are called as inflammable substances. Is that clear?
Sir, inflammable or flammable?
It's inflammable. Inflammable substances, in other words, means that a substance which is easily set on fire, right now. Also, we can kind of in a similar manner understand it, just like we talked about combustible substances right now. So the substances that are going to have low ignition temperature, they are going to easily catch fire. So you can have several examples. Talking about the examples are as follows. We have CNG, you have LPG, yeah, you have petrol, diesel, kerosene oil, you have biogas. All these are the examples. You can have one, we have one more example, alcohol. Getting it, guys? They have low ignition temperature, while there are some fuels that have high ignition temperature now. Okay, you guys give some examples of fuels that are having high ignition temperature.
Crude oil.
See, crude oil is going to have high ignition temperature, correct? But crude oil in itself is not a fuel. It's an impure form of petroleum. Now, petroleum, it's an impure state. It has to go through the purification process. Then you obtain different fuels from it. Okay, you guys tell me about some of the fuels. For example, what can you say about which one? Coal. Very good. You have examples as follows.
Sir,
Coal,
charcoal.
Wood also.
charcoal,
Sir,
wood.
that
Yep.
lead or something? Lead?
Repeat
Sorry,
again.
peat.
Peat. Very good. Coal, basically in the coal you will have all different types of examples of coal. Now, there you can count it. Peat, bituminous, subbituminous, anthracite, everything will be counted there. Apart from wood, the most common example, particularly it is used in India, cow dung cakes. Cow dung cakes.
Sir, that
So,
sambran.
once repeat again.
In the stick, the smoke will come out. The stick, sambrani.
Oh, okay. You're talking about that thing. That is also there, but particularly here we are talking about fuels. In case of fuels now, okay, now that can also be taken as one such example, but that one is an example of I believe it would be taken in the case of low ignition temperature.
And does diesel count?
Which one?
Diesel.
Diesel. Please repeat again.
Diesel.
Okay, that thing. Hazel leaves, are you saying?
What's a diesel?
Okay, nasal.
What's a diesel?
Oh, sorry. Diesel. Or diesel will be counted in the case of low ignition temperature, no? Diesel. We forgot to write it over here, no? Okay. My bad. So diesel is, yeah, it's having low ignition temperature. So particularly the substances, let me write the definition, the substances that have low ignition temperature, I mean to say high ignition temperature, are called as non-inflammable substances right now. They are going to be called as non-inflammable substances. I hope you guys are getting it. Okay. Are called as non-inflammable substances. Further, if you were to talk about like this thing, this activity, for example. Okay, we'll be discussing about activity in a while. First of all, let us understand about this thing, types of combustion. Okay, no? What are the different types of combustion which we have? See, some of the some types of combustion are some combustions are very rapid, meaning that in some type of combustions, large amount of heat and light is going to be produced in a very short period of time. For example, when we bring a lighted matchstick or a lighted lighter near the gas flame, near the gas stove in the kitchen, cooking gas starts burning once it starts to burn immediately and produces lots of heat and some light also. So this immediate burning of cooking gas, that is basically liquefied petroleum gas, is one such example of a rapid combustion. Right now, where you don't have to wait for the substance to catch fire. Right? Then there are some reactions in which the substance can catch fire on its own, meaning that, I mean to say that it will go through combustion reaction on its own. Like in the case of lighting a stove, what were you doing? You were providing an external source of heat to it by using a lighter or matchstick. But in some cases, the combustion reaction is going to occur on its own without the help of any external heat. So there, what basically happens? The substance suddenly burst into flames and it starts to burn. Even without being heated from an external source, it starts to burn. And spontaneous, that type of combustion is called as spontaneous combustion, and that can take place even at the room temperature. So we say that the heat that is required for a spontaneous combustion to take place is produced inside the substance. By the way, there would be some slow oxidation taking place inside it right now. To do one thing, this topic, different types of combustion. Now, in the next class, we're going to talk about the rapid combustion. We're going to talk about the spontaneous combustion, and there's one more example of combustion, that is explosive combustion. What are these three types of combustion? Okay, now, and how they are different from each other. By the way, this spontaneous combustion that I was talking about, let me just complete this one. By the way, you might have seen that forest fires would be spontaneously taking place now. We didn't, or not, it's not like someone went there and lit the forest on fire. Most of the forest fires are, however, caused due to the carelessness of human beings when we throw away lighted cigarettes in the forest or leave behind a burning campfire after having a picnic in the forest. Those are also the causes.
Sir, lightning also, right?
Lightning is also one of the causes for forest fire. Very good, Alif. So we are left with three topics in this thing. Like talking about types of combustion, you're going to have rapid, spontaneous, and then explosive combustions. We'll be talking about them in the later class. Okay, no? Okay. Also,
Yes, sir.
Gauri, you need one more class for that chapter, metals and non-metals. Okay, now.
Yes, sir.
So whenever you'll be available, we'll be having an extra class for that chapter. Okay, so that's it for
Okay,
today.
sir.
We'll be meeting in next class then.
Sir,
Yes.
Thank you, sir.
I was wondering if I could get an extra class because I'm having a test for a chapter in physics.
Okay. What's the chapter name, by the way?
Force and pressure.
Force and pressure. Okay, sure. Extra class will be scheduled. When is your exam? I believe it's on 12th.
It's on Tuesday.
It's on this Tuesday.
Yeah.
Okay. So